OmniParse takes messy files, documents, images, audio, video, and web pages and turns them into LLM-ready Markdown or JSON. The proof is not a mockup. It comes from the official GitHub demo. The source is a Tom Door post pointing to the OmniParse repository. I verified the post through public X mirrors, then used GitHub and the project homepage for the actual product claims. The repo has over 7,000 stars and hundreds of forks. This matters because AI apps often fail before the prompt even reaches the model. PDFs, screenshots, recorded calls, tables, and web pages all arrive in different shapes. OmniParse is trying to be the ingestion layer that normalizes that mess. The README and official demo make 4 important claims. OmniParse can run locally without external APIs. It uses deep learning models. It is described as T4 and collab-friendly. And it exposes both the Gradio interface and API endpoints.
Hi guys, Aditya SK here. Really excited to introduce OmniParse. If you guys have built AI applications, you understand that clean and structured data is really important. But the process of acquiring and processing this data at scale is really hard. OmniParse tries to solve this. It's an open source data ingestion and parsing platform which converts your unstructured data into structured, actionable outputs that can be directly fed into your AI applications. The best part about this, it works completely locally without the use of any external APIs and relies on deep learning models. It conveniently fits on your T4 GPU and it is also Google Colab friendly. We are currently running it on a Google Colab as well. It's really easily deployable and you can deploy it using Docker. After you have set up the project, you mainly get an API interface like this, but also you can interact with the UI. We support multiple data formats from documents, images, multimedia to the web as well. So let me just demonstrate how the document works. So let me just upload a research paper here. And after parsing the document, you get a structured Markdown response here. So it extracts the title, it extracts the text properly, along with which it also extracts formulas in a clean format, and it extracts the tables here as well. It also supports multiple languages, as you can see. It supports Tamil, Telugu, a lot of stuff. And it also extracts images at the end that you can use in your multimodal RAG applications. And you can also conveniently see the output JSON and integrate with your current existing applications as well. Coming to images, let me just feed in this image here. It looks something like this. And after parsing it, as you can see, you get a structured text extraction here, and it also extracts the image. Now let me just caption the same image and see what you get. Yeah, as you can see, it is able to extract the title of the paper and also give you a good caption that you can caption the image as well. Coming to media, you can throw in any type of audio or video file, and you can get a structured Markdown response out of it as well. And also it supports web, so you can just feed in a link and pass the link, and you get a structured response that you can directly feed into your application. You also get a screenshot which you can perform OCR on top of. So we are already at 400 stars, and if you found this project valuable and useful, a star would be much appreciated. Thank you.
The repo docs show the API shape. Documents go through parse document. Images go through parse image. Audio and video go through parse media. Websites go through parse website. The goal is one pipeline that feeds AI apps clean, structured output. The official demo output is the strongest proof. You can see structured Markdown, JSON, extracted text, images, and captions. This is why the video focuses on source footage instead of inventing a fake terminal run. Here is the setup reality check. Open source does not mean zero infrastructure. The README says the server only works on Linux-based systems, and the model stack can be compute-heavy. I am not faking a macOS terminal run for a Linux-only setup. The official path is clone the repo, create a Python 3.10 environment, install with Poetry or editable pip, then run server.py with the documents, media, and web flags you need. For a true tutorial, this should be recorded on a Linux or GPU machine. If you're evaluating this for your own stack, start small. Test one representative PDF, one image, one audio or video file, and one web page. Check whether the Markdown is clean enough for retrieval, whether tables and formulas survive, and whether the JSON shape matches your application before you scale it. There are a few caveats. The homepage lists the open source option as not scalable and compute heavy. The hosted version is a waitlist or sales flow. The docs domain did not resolve during review, so the repo docs are the stable source. Also, the license metadata conflicts, so I treat the license file and GitHub API as source truth. The verdict is simple. Use OmniParse if you need private ingestion before retrieval augmented generation or other LLM workflows. Skip it if you want a zero setup cloud parser today. The interesting part is the scope: documents, images, media, and web content in one self-hostable parser.